Hello there, and welcome. I'm so glad you've chosen to join me here in this quiet space we call the Midnight Scientists, a place where our curiosity can get comfortable, where the vast questions of the cosmos are whispered like bedtime stories. Tonight, we're going to embark on a gentle journey together, a slow drift through the soft, velvet darkness of the night sky, tracing the shimmer of distant stars to answer a question as ancient and as comforting as the night itself. Why do stars twinkle? My deepest hope is that this journey helps your mind to quiet and your body to unwind, guiding you gently towards sleep. But if you find your mind is still quietly curious, still listening, that's all right too. Sometimes the most peaceful rest comes after we've been given something beautiful to dream about. There is no rush here. Simply be. Before we begin our gentle ascent into the stars, if you feel this space brings you comfort, you might consider leaving a like, a silent, soft press of a button that helps other sleepy minds find their way to this calm harbor. And if you wish to return, you can always subscribe, ensuring this peaceful place is here for you whenever you need it. I often wonder where you are in the world as you listen, what the night looks like outside your window. If you feel so moved, you can share your location and your time of night in the comments. A quiet greeting from your corner of the world to mine. Are you just now climbing into bed? Or has the deep, quiet dark already wrapped itself around your home like the softest of blankets? Wherever you may be, whatever time the clock may show, let's allow ourselves to get cozy now. Let your body grow heavy, let your breath slow, and let us gaze up together into the deep and patient sky. The stars, they have been waiting for you. Chapter 1. The Earth's Gentle Deception. Let us begin with that beautiful, simple question, one you have likely whispered to yourself on a clear night while looking up into the endless dark. Why do stars twinkle? You have seen it, a distant star flickering softly in the black tapestry above, winking and shimmering as if it holds a gentle secret. It's a sight that is at once mysterious and profoundly soothing. But what is this gentle dance? What is happening in the vastness of space? Or perhaps, more accurately, what is happening much, much closer to home that causes these distant suns to sparkle like cosmic dust scattered on velvet? The first secret, the most fundamental truth, is that the stars themselves do not actually twinkle, not in the way we perceive them. If you could float weightlessly above our world, above the thin, protective veil of our atmosphere, out there in the profound silence of space, you would see the stars as they truly are, steady, unwavering points of bright, calm light. There would be no flicker, no shimmer, only the serene, unblinking gaze of distant fire. So, if the stars are stable beacons in the cosmic ocean, then the twinkling, the beautiful illusion, must be happening somewhere between them and us. And indeed it is. The cause is our own planet's gentle, invisible blanket of air, the Earth's atmosphere. Consider the immense journey that starlight must take to reach you. It travels for years, centuries, millennia, across the cold, silent emptiness of space. For trillions upon trillions of miles, it crosses the void without so much a wobble. But then, in the final fleeting moments of its epic voyage, just the last 100 kilometers or so, it encounters our atmosphere. And here, in this final delicate layer, things become a little more fluid. You see, the Earth's atmosphere is not a still, uniform shield. It is a living, breathing ocean of air, constantly moving, stirring, and changing. It is filled with countless invisible currents, layers of different temperatures, pockets of varying density and moisture, and the gentle, unseen rivers of the wind. Think of it less like a pane of glass and more like looking up from the bottom of a very clear, very calm river, where the water is always subtly flowing and bending the light that passes through. As the ancient starlight enters this moving ocean of air, it is gently bent. This bending of light is called refraction. You have seen this gentle magic before. Perhaps you've noticed how a straw in a glass of water appears to be bent at the surface. The same principle is at work in the sky above you, but on a scale that is almost impossibly vast and complex. Now, picture that single, unwavering ray of starlight passing through layer after layer of our atmosphere. Each layer has a slightly different temperature, a slightly different density. The light bends once, then bends again in a slightly new direction as it meets a pocket of warmer air. Then it shifts again as it passes through a cooler, denser patch. It doesn't travel in a perfectly straight line anymore. Its path is now a gentle, wandering dance. By the time that light finally completes its journey and arrives at your eyes, it appears to be shimmering, ever so slightly, twinkling. This beautiful effect has a scientific name: stellar scintillation. It sounds like a phrase from a poem, doesn't it? Stellar scintillation, the shimmering of the stars caused by the gentle turbulence of the air between them and you. Interestingly, the position of a star in the sky changes the intensity of its twinkle. Stars that are closer to the horizon appear to twinkle much more dramatically. This is because the light from those stars has to travel through a much thicker, denser slice of the atmosphere to reach you. It must pass through more of that stirring, shifting air, which means more bending, more distortion, more twinkling. The stars that are directly overhead, at the zenith of the sky, have the most direct path to your eyes. Their light pierces the atmosphere at its thinnest point, encountering far less turbulence. And so they twinkle less. They shine with a steadier, calmer light. Though if you watch closely, you can still see a gentle, subtle flicker, like a distant candle flame breathing softly in a quiet room. This atmospheric dance is a gift, a beautiful imperfection. It is the Earth's atmosphere, the very air you are breathing now, that adds this touch of magic to the distant, ancient stars. It is a final, gentle signature from our world upon the light of the universe. Chapter 2: The Calm Gaze of the Planets. Now, here is something you may have already noticed on your own quiet nights of stargazing. Not everything in the sky twinkles. If you have ever looked up and spotted a bright, steady beacon of light, a point of brilliance that shines with an unusual calm, chances are you were not looking at a star at all. You were likely gazing upon a planet. Perhaps the gentle glow of Venus or the steady light of Jupiter. Planets our celestial neighbors shine with a serene, unwavering light. But why? They are also in the sky. Their light must also pass through our same turbulent atmosphere. Why do they appear so different? The answer, quite simply, comes down to their apparent size. Stars, even the largest ones, are so profoundly far away that from our perspective on Earth, they are infinitesimally small points of light. All of their immense fiery brightness is concentrated into a single sharp pinprick. When our moving atmosphere bends the path of that single point of light, even by a tiny amount, the entire star appears to jump or flicker. You notice the change instantly. It is all or nothing. Planets, however, are so much closer to us. They are our companions in this solar system. Venus, at its closest, is a mere 25 million miles away. While that is still an immense distance, on a cosmic scale, it is practically next door. Because they are so much closer, planets do not appear as single points. Through a telescope, they are clearly visible as disks, and even to our naked eye, they behave like disks of light. Now, imagine the light from that small circular disk of a planet entering our atmosphere. The air still bends the light, just as it does with starlight. But the effect is averaged out across the entire surface of the disk. The light from the top edge of the planet might be bent slightly downwards, while the light from the bottom edge is bent slightly upwards. One part might flicker brighter for a moment, while another part flickers dimmer. These tiny, countless distortions effectively cancel each other out. The overall brightness and position remain remarkably stable. The result is not a flicker, but a calm, steady glow. Think of it this way. Looking at a twinkling star is like seeing a single, tiny sequin fluttering in the breeze. But looking at a planet is like seeing a small illuminated pearl. The air may stir around it, but its glow remains constant, serene, and whole. This simple difference was not always understood, of course. For most of human history, people looked up and saw these shimmering lights as something magical, perhaps even alive. Some ancient cultures believed they were the watchful eyes of their ancestors, their loving gazes glinting in the darkness. Others imagined they were divine lanterns lit by gods and trembling gently in the celestial wind. Even the word itself, twinkle, feels whimsical, doesn't it? It is a soft, lyrical word. It dances on the tongue. It's no wonder it found its way into our lullabies and nursery rhymes. Twinkle, twinkle, little star. A simple question from a child's song that holds within it a profound cosmic truth. Beneath that childlike wonder lies a world of beautiful physics, quietly humming away every single night. So, the next time you gaze up into the night sky, let your eyes wander. See if you can find them. The shimmering, dancing points of light, those are the distant suns, the ancient stars. And see if you can find the calm, steady ones, the ones that hold their light with a quiet confidence. Those are the planets, our neighbors. One twinkles because it is a distant point, the other glows because it is a nearby world. And our own atmosphere is the artist that reveals the difference. Chapter 3: A Photon's Epic Journey. Let us imagine something truly beautiful for a moment. Let's trace a single particle of light, a photon, on its incredible journey from a star's heart across the vastness of space all the way to you. Somewhere out there, unimaginably far from here, a star is burning. It may be a young, hot blue star or an ancient, cool red giant. Deep within its core, where pressure and temperature are beyond our comprehension, nuclear fusion is constantly at work. In this cosmic furnace, atoms are forged, and in that process, enormous energy is released. Some of that energy takes the form of a photon, a tiny, weightless packet of light. Our photon is born, but its journey has barely begun. It does not simply fly straight out of the star. Instead, it begins a chaotic, staggering path through the star's dense interior. For thousands, even hundreds of thousands of years, it is absorbed by one atom, then re-emitted in a random direction, only to be absorbed by another. Its path is a zigzagging, seemingly endless dance, a journey that can last longer than all of recorded human history just to escape the star that gave it birth. And then, one day, it finally breaks free from the star's surface. It bursts forth into the silent, open vacuum of space. Now, its journey becomes smooth. Photons travel at the speed of light, the ultimate cosmic speed limit. They do not tire, they do not slow down. They are the universe's most patient and relentless travelers. For millions or even billions of years, our photon may coast through the near-perfect emptiness. Out here, there is very little to disturb its path. It sails past vast nebulae of dust and gas. It curves gently around the gravitational fields of other stars and unseen worlds. It is a silent, solitary traveler on an immense ocean of darkness. The light you see from the stars tonight did not begin its voyage this evening. It began long, long ago. If you look at a star that is 100 light-years away, the photons reaching your eyes tonight began their journey a century ago. When they first left their star, the world here was a very different place. And yet, that light traveled on, patient and true. The light from the Andromeda Galaxy, our closest galactic neighbor, has been traveling for over 2.5 million years to reach you. When that light began its journey, our earliest human ancestors were first walking the earth. Let your mind rest on that for a moment. The sky above you is not just a picture of the present. It is a deep, living tapestry of the past. Each star is a snapshot from a different time. After its long, peaceful voyage through the vacuum, our photon finally approaches its destination, our small blue world. In the very last fraction of a second of its multi-million-year journey, it plunges into Earth's atmosphere. After the serene silence of space, this is a dramatic change. It enters the swirling, churning sea of air molecules. Its perfectly straight path is now nudged and jostled. Instead of a single straight run, it is like a smooth stone skipping across a gently rippling pond. Its path is bent this way and then that way by the invisible currents of heat and wind. And then the journey ends. That single photon, which may have been born before the dinosaurs, which traveled across unimaginable distances, finally comes to rest in the retina of your eye. Your eye is so incredibly sensitive that in perfect darkness, it can detect the arrival of just a handful of photons. What you perceive as a twinkle is the final, fleeting chapter of that photon's cosmic story. It is a handshake across time and space, a brief, shimmering connection between a distant, ancient star and you, lying here now, watching and breathing. The star isn't just a glow in the distance. It is a physical message delivered by the universe and translated into a gentle, sparkling dance by our very own atmosphere. You are not just an observer of this story, you are its conclusion. Chapter 4: The Whispers of Ancient Skies. Long before we had the language of science, before photons and refraction, humans were watching the stars. For countless generations, on every continent, people would lie under the night sky, just as you might be doing now, and they would wonder. They saw the same shimmering lights, and they did what humans have always done when faced with a beautiful mystery. They told stories. The twinkling of the stars was woven into the very fabric of their myths and beliefs. It was not a trick of the air. It was a sign, a message, a living pulse in the heavens. In ancient Greece, the stars were often seen as heroes and gods, placed in the sky by Zeus himself. The shimmering light was the glint of their divine armor, or perhaps the hero winking down at the mortal world. The constellation of Orion the Hunter, when his bright stars twinkled in the winter sky, was seen as the great hunter himself, his bow drawn and shimmering in the eternal darkness. In the deserts of Australia, the Aboriginal peoples, who hold some of the oldest continuous cultural traditions on Earth, read the twinkling stars like a book. For some, the shimmering points of light were the glowing embers of the campfires of their ancestors, burning peacefully in the sky world. A rapid twinkle might mean the spirits were active, watching over their descendants with love and care. In ancient Japan, there is the beautiful and sorrowful tale of Orihime, the weaver princess, and Hikoboshi, the cowherder. They are represented by the two bright stars Vega and Altair. They were lovers, so deeply in love that they neglected their duties and were separated by the gods, placed on opposite sides of the great celestial river, which we know as the Milky Way. They are allowed to meet only once a year, on the seventh night of the seventh moon. On that night, if the stars Vega and Altair twinkled brightly, it was believed the lovers were joyful in their reunion. The Vikings of the North believed the sky was the giant skull of Ymir, and the stars were sparks from the primordial fires of Muspelheim caught in the dome above. Their flickering was the crackling and shifting of those distant cosmic flames. For ancient mariners, from the Polynesians to the Phoenicians, the stars were not just stories. They were essential tools. They noticed that some stars, like Polaris, the North Star, shone with a greater steadiness. Its reliable, less twinkling light became a fixed point in a moving world, a guide for navigating the vast, dark oceans. Its constancy was a symbol of hope and stability. Knowing the science behind the twinkle doesn't erase the magic of these stories. In fact, it adds a new layer of wonder. It tells us that our ancestors were keen observers. They noticed the difference in twinkling near the horizon. They saw the steadiness of the planets. They weren't wrong to see life and meaning in the stars. They were simply speaking a different language, a language of poetry, of spirit, and of awe. So, as you look up at the twinkling stars tonight, allow yourself to imagine those ancient eyes that watched them before you. Imagine the stories they whispered in the dark, stories of gods, heroes, lovers, and ancestors. The sky you are watching is the same sky they watched. The twinkle you see is the same gentle flicker they saw. You are part of a chain of wonder that stretches back to the dawn of humanity. Chapter 5. Seeing Through the Shimmer. For as long as we have told stories about the stars, we have also tried to measure them. This desire to understand, to bring order to the beautiful chaos of the sky, is also deeply human. But for astronomers, both ancient and modern, the very same twinkling that inspires poets and lovers can be a gentle frustration. Imagine trying to read a book while someone is gently shaking the page. That is what it's like for an astronomer trying to get a precise measurement of a star's brightness or position through our shimmering atmosphere. The dance of light makes their work incredibly difficult. And so, for centuries, science has been on a quest to de-twinkle the stars. One of the simplest solutions is also the oldest: go higher. This is why the world's greatest observatories are not built in valleys or cities, but are perched atop remote, towering mountains. Places like Mauna Kea in Hawaii or the Atacama Desert in Chile. Up there, the air is thin, dry, and cold. The telescope is above the thickest, most turbulent layers of the atmosphere. There is less air for the starlight to travel through, and therefore less twinkle. But even on the highest mountains, the air still moves. And so, modern astronomy has developed an ingenious technology called adaptive optics. It is a marvel of engineering that essentially cancels out the atmospheric blur in real time. Think of it like this. The telescope uses a flexible mirror that can change its shape hundreds of times every second. A powerful laser creates an artificial star high in the atmosphere. A sensor watches how the light from this artificial star is distorted by the air. A computer then calculates the exact opposite distortion and instructs the flexible mirror to bend and warp itself, precisely canceling out the atmospheric shimmer. The result is a beautifully clear, steady, pinpoint image of a star. It is as if the telescope has taken a deep, calming breath, and the sky has become perfectly still. Of course, the ultimate way to beat the atmosphere is to leave it behind entirely. This is the dream that gave us the Hubble Space Telescope. Floating silently in the vacuum of space, more than 300 miles above the Earth, Hubble sees the universe with perfect clarity. There is no air, no turbulence, no weather, and no twinkling. The breathtaking images Hubble has given us of swirling galaxies, glowing nebulae, and the birth of stars are possible because it is free from our planet's atmospheric shimmer. And now the James Webb Space Telescope, orbiting 1 million miles from Earth, peers even deeper into the cosmic dawn, seeing the universe in light that is invisible to our eyes, completely undisturbed by the air that gives us both life and twinkling stars. It's a beautiful thought, isn't it? That so much of our most brilliant science, so much effort and ingenuity has been dedicated to overcoming this one gentle, poetic illusion caused by the air above our heads. In our quest to see the stars as they truly are, steady and unwavering, we are reminded that our perspective from Earth is unique. We live inside the gentle river of air, and the stars we see are forever filtered through its soft, moving currents. Chapter 6. The Soothing Stillness of the Sky. Let us shift our gaze one last time, not outward toward the stars, but inward. Because while the science is fascinating, there is another equally important truth: the simple, profound effect that stargazing has on us. There is a reason why looking up at the night sky feels so calming. It is an act of awe. Psychological studies have shown that when we experience awe, that feeling of being in the presence of something vast that transcends our understanding, it has a measurable effect on our minds. It quiets the part of our brain associated with our own worries, our to-do lists, our sense of self. Under the vast, silent canopy of a starry sky, our own concerns seem to find their proper scale. They don't vanish, but they are held in a much larger context. The universe reminds us, in the gentlest way possible, that we are a small part of a very large, very beautiful story. And there is a deep sense of peace, a quiet relief in that feeling. As you lie here, your body responds too. Your breathing naturally slows and deepens. Your heart rate may soften. Your muscles can release the tension they've held throughout the day. Focusing your eyes on distant points of light allows the tiny muscles in your eyes to relax, easing the strain from looking at screens and close objects. It is a physical as well as mental form of release. Watching the gentle, rhythmic, and unpredictable twinkle of a star can be a form of meditation. Your mind doesn't have to try to be still. The sky invites it to be still. Your thoughts can begin to drift and wander, not with anxiety, but with gentle curiosity. You are not solving or planning. You are simply being, present. And perhaps most wonderfully, stargazing connects us. You may be in your own bed, in your own home, but as you look up, you know that across the world, other people are looking up at these very same stars. You are sharing a silent, universal experience, a connection to the past, to all those who have looked up before you, and a connection to the present, to everyone else sharing this quiet moment. The twinkle, that gentle shimmer, is a reminder that the sky is not a static painting. It is alive. It is breathing. It is the Earth's atmosphere interacting with ancient light. And you are here, a part of it all, safe, quiet, and connected to everything. Conclusion: drifting among the stars. And so we find ourselves at the end of our gentle journey tonight. We have wandered from the science of our atmosphere to the myths of our ancestors, From the epic journey of a single photon to the quiet stillness in our own minds, all inspired by that one simple, beautiful question: why do stars twinkle? The answer, we've learned, is the Earth's atmosphere, a blanket of air constantly in motion that bends the ancient light of distant stars, making them appear to shimmer and dance just for us. It is an illusion, but it is our illusion, a beautiful local phenomenon that makes our view of the cosmos unique. Somewhere out there, as you are listening to these words, light from a star that began its journey long, long ago is just now arriving. It is passing through those final layers of air, and its steady glow is being transformed into a soft, gentle flicker, a twinkle that might just land in your eye. I hope this journey into the stars has brought you some peace, some calm, and has helped quiet your mind. I hope it has given you a soft place to rest your thoughts as you drift toward sleep. The stars will continue their silent watch over you as you rest, and our atmosphere will continue to make them twinkle, a soft, celestial lullaby just for you. Sleep well, my dear listener. May your dreams be filled with steady light and soft, gentle shimmer. Good night.